In previous videos, we converted this 3D structure into a skeletal structure, and we looked at shapes about central atoms. And you can see the shapes better in this 3D molecule. This time I'm going to label the shapes in this 2D molecule and add one more possibility of linear. So we've seen tetrahedral. That usually happens at carbon when four things are attached. So let's go through and look. Each of these carbons, you can see it's very flat there. Each of these carbons has three things attached, not tetrahedral. All of these carbons have three attached, not tetrahedral. Here, there's a double bond, not going to be tetrahedral. Right here, we've got one with four things attached. That one's going to be tetrahedral. This has three. 1, 2, 3. This carbon out here with its three hydrogens, that one's going to be tetrahedral. So we've only found two carbons in this whole thing that are tetrahedral. Okay, trigonal pyramidal. We saw those with nitrogen when it had three things attached in a lone pair. There's 1, 2, 3, so it's got to have a lone pair because it has no charge. This nitrogen's going to be trigonal pyramidal. We've got one of those. This nitrogen, on the other hand, only has two attached. So one of them, we figured out, has to be a double bond. And it has one lone pair. That makes this one bent. We also saw bent with oxygen, but here the only oxygen's out on the end, so its shape is not a relevant thing. It makes a line to the carbon. So we got one atom that's bent. Trigonal planar, we saw that a lot with anything that had a double bond. So every one of these carbons has a double bond and something else attached out. These are all, we're doing P for planar. You may have noticed by now that aromatic rings are flat, very flat. Now the chlorine, we don't talk about its shape since it's out on the end. What do we have left? We've got a carbon here. It's got a double bond and two single bonds. It's also planar. We've got a carbon here. It's got a double bond and two single bonds. That's also planar. We've now covered every atom in the molecule. So a lot of planar 6, 7, 8, and 6 more, 14. Linear is one we haven't covered. You get that when you have something like two double bonds or a single bond and a triple bond. And you'll remember, you may have to look back at your general chemistry shapes to refresh your memory on why they form that linear shape with the electrons repelling each other. So we've covered essentially all the shapes you'll ever see in organic chemistry or biochemistry. They're just 6, pretty easy to identify. We could put angles with them. Tetrahedral is going to be approximately or exactly 109.5 degrees. Trigonal pyramidal is going to be about the same. Well, less than or approximately 109.5. Trigonal planar is going to be approximately 120 degrees or exactly that. Linear will be exactly 180 degrees. And bent can come from trigonal pyramidal or trigonal planar depending on how many lone pairs of electrons there are. So it's either going to be about 109.5 or about 120. You'll see, yeah, and we have one of each here. Oh, no, we've just got ones that are about 120 in this molecule.